Hello friends, welcome to my e-clinic. If you are new to my channel, don't forget to subscribe for recent updates. So after studying about dental lamina, morphological stages of tooth development and the Hertwig's epithelial root sheet, let's now study about the histophysiology of the development of tooth. Friends, sincere request to watch my earlier videos. Watching videos in their sequence will help you to enhance your knowledge and understand the topic better. The link of previous videos are provided in the description box. So without any further delay, let's begin with our today's topic, which is the histophysiology of odontogenesis or the development of tooth. So first remember that the process of odontogenesis is not a momentary event. It is a continuous process. This continuous process involves these events. These are initiation, proliferation, histodifferentiation, morphodifferentiation, and apposition. Now remember, these processes are described different in a different heading, but still each of these physiologic process is not individual. They tend to overlap with each other. Each of these physiologic process tend to predominate in one morphological stage, but they overlap with each other. For example, the process of initiation is predominantly seen in the dental lamina. Then the process of proliferation can be seen in the bud stage and the cap stage. The process of histodifferentiation can be appreciated in cap stage, bell stage, and advanced bell stage. The process of morphodifferentiation can be seen in bell, advanced bell stage, and the step of enamel and dentine formation. And finally, the process of apposition can be well appreciated in advanced bell stage and in the stage of formation of enamel and dentine. So let's begin with the first process. This is the process of initiation. Now we have seen in the earlier lectures that there are only certain cells on the dental lamina that have the potential to form teeth. Okay, so suppose this is the dental lamina and this is the ectomesenchyme present beneath the dental lamina. Now what happens is that this ectomesenchyme sends some signals to the dental lamina. So it sends some signals to the dental lamina. Now what are these signals about? These are nothing but the instructions to the dental lamina to begin with the tooth development. Okay. Now how does this dental lamina respond to these signals? There are certain cells present on the dental lamina which have the potential to initiate the tooth development. These cells begin to divide rapidly and this initiates the tooth development process. And they form knob-like structures on the dental lamina which marks the initiation of the root formation. Now also keep in mind that this process is a classic example of epithelial ectomesenchymal interaction. Let me explain this interaction again. The ectomesenchyme sends some signals to the dental lamina to begin with the tooth development. In response to these signals, the dental lamina begin to rapidly divide at certain areas and initiate the odontogenesis. Okay. Now after initiation, the next stage is proliferation. This is the dental lamina which have shown the initiation of root formation by forming knob-like structures at certain places. Now, in this process of proliferation, these cells which have initiated tooth development, they undergo proliferation. They divide more rapidly. Change in size and shape occurs in the enamel organ to form various stages of tooth development like the cap stage, the bell stage, the bud stage, Okay, so proliferation of the cells causes the enamel organ to assume various shapes. Now the next step after proliferation is the histodifferentiation. So what happens in histodifferentiation is that the cells of the tooth germ, they undergo definite morphologic and histologic process. For example, the inner enamel epithelium. So this inner enamel epithelium, it induces the dental papilla cells to form the odontoblast. Now once these odontoblasts are formed, these odontoblasts begin with their function of dentine deposition. These odontoblasts forms the dentine. Now once this dentine is formed, under the influence of this dentine, the inner enamel epithelial cells, they differentiate into ameloblast. And these ameloblasts then begin their function of deposition of enamel over the dentine. This is also a very overlapping event, and this phase reaches its highest development in the Bell stage. In the Bell stage, we can appreciate the histodifferentiation in process. Okay, so we can appreciate this histodifferentiation in the Bell stage. Now, this deposition of dentine and the enamel also is an example of epithelial ectomesenchymal interaction. So now, let me explain you in detail how this epithelial ectomesenchymal interaction occurs. The inner enamel epithelial cells instructs the dental papilla cells to form odontoblasts. Now, once these odontoblasts are formed, they begin to lay down the dentine. When this dentine comes in contact with the inner enamel epithelial cells, these differentiate into ameloblasts. And these ameloblast cells then lay down the enamel. So here we can appreciate easily the epithelial ectomesenchymal interaction which occurs during the deposition of the dentine and the enamel. Now the next process after this is the morphodifferentiation process. It marks the process of the advanced Bell stage. In the advanced Bell stage, we can easily appreciate the process of morphodifferentiation. According to this, the dentino-enamel junction and the cemento-enamel junction, they act as blueprint. The dentino-enamel junction and the cemento-enamel junction, they act as blueprint, and in reference to this blueprint, the enamel and the dentine and the cementum is formed. So the DEJ and the CEJ acts as a blueprint on which the enamel, dentine and the cementum forms over the root. Now, after morphodifferentiation, the final process of odontogenesis is the apposition. In the process of apposition, the enamel, dentine and cementum formation takes place. There is an appositional growth of enamel and dentine in layers. Okay. So this is an additive process. Remember, this is an additive process. The layers of enamel, dentine and cementum are added upon each other. The process of apposition fulfills the plans outlined in the histodifferentiation and the morphodifferentiation process. The individual process of enamel formation, dentine formation and cementogenesis will be discussed in detail in the separate upcoming lectures. That's all for now. Please don't forget to like, share and subscribe to my channel.